When graphing inequalities, the biggest thing you have to remember is whether the circle on your number line is open or it's closed. When you have less than or greater than, it creates an open circle because the solution is your starting point, but it's not part of your solution set. When you have less than or equal to, greater than or equal to, the circle is closed because that is part of your solution set. So in this first example, we have x is less than 6. So to graph that, x's value can be anything less than 6. So we have 6 in the center. Give yourself one above, which is 7, one below, which is 5. So because it is only less than, it is an open circle at 6, and less than, so x is less than 6, so any number less than 6 is part of your solution set. So you shade the arrows and all your numbers less than 6. Notice how the open circle is on the 6. The shading is on the actual number line itself, not floating above. This next one, x is greater than or equal to negative 3. So again, you have your number line at negative 3, negative 2, and then negative 4 over here. X is greater than or equal to, that's this symbol right here, negative 3. So it is a closed circle because x's value can also be negative 3, not just greater than it. So greater than or equal to means everything to the right is shaded and filled in like that. So in this one, you'll notice that the 5 comes before the x. So we're still going to do our number line. We're still going to put the number 5, put the number 6 above, put the number 4 below. It's still going to be an open circle, but when you read these, when you have your 5 first and then your x, you actually have to read them backwards. If 5 is greater than all of x's values, that means x is less than 5. Less than 5. Same concept here. You have it backwards again, so you can put the 6 here. 5. So closed circle because it's less than or equal to. But if 6 is less than or equal to x, that means x, if I'm reading it left to right, is greater than or equal to 6. So x is greater than. So that's this way. If you're ever confused with which direction to graph it, simply pull a number. So let's start with this first example. So I shaded over the number 5. If I plug 5 in here, is it true? Is 5 less than 6? The answer is yes, it is part of the solution set. So if I jump to the next one over here, if I said, okay, well, let me pull negative 4. I didn't shade over negative 4. So negative 4. Is negative 4 greater than or equal to 3? No, that's not true. It's not part of your solution set. But if I pulled negative 2, and I put that there, negative 2. Is negative 2 greater than or equal to negative 3? Yes, that is true. So sometimes with the ones where they're backwards, it's a little difficult. So to try to figure out exactly which way to shade, pull both numbers. So pull 4 and pull 6. And say, all right, which one is going to make the inequality true? 5 is greater than, not 4, so it's got to be 6. I so lied to you. 5 is greater than 4, not 6. So you're shading over the 4. And then the same with this one. You pull 5 and 7. 5 is greater than, or 6 is less than or equal to 5. Not true. 6 is less than or equal to 7. So you shade over top of the 7. So that's a foolproof way to know which way to shade.